All right. Welcome back, everybody, to Comerit's What's Up Enterprise podcast, where we explore the latest technology trends across industries with the leading experts from around the globe. Today, we've got a great guest. Vlad, thank you so much for joining us. Vlad Kolonoskov. He's an AIML expert from Google. And I won't go into too much detail because I think he'll have a great description of his background. So I'm going to let him talk for a minute. Vlad, could you tell us a little bit about how you got to where you're at?
Hi, everyone, and thank you for having me, David. Very excited to talk to you today. So my background is essentially computer science and engineering. I went through different technologies, through different waves since I think 1999, starting from CAD and low-level tools development back then for Windows, mixed reality, and then later with AI. Obviously, these days there's a lot about generative AI and data and analytics. That's where I'm focusing today. And in my most recent role, which I actually start on Monday, I'm going to be working on helping people to bring their generative AI application to production.
That's awesome. Yeah. So it's obviously it's a very hot topic right now. I mean, AI in general,
Mhm.
generative AI, and what people are doing with use cases. So I have lots of questions. You had previously come from another organization. Can I ask how you ended up with Google? Like, what was that process? Like, what were
The
the
process, I mean, it's the usual process. You're looking for new opportunities, and I felt that data and analytics is a huge area to cover. Yeah, both with what traditional ML is, things like anomaly detection or forecasting, and obviously now with generative AI, and that was before generative AI hype. Data analytics was a huge interest of mine, so I decided to kind of pursue these opportunities, and there was a role at Google, and that's how I ended up with previously the Cortex team,
awesome?
which you have a few guests from, I know, on this podcast.
Yeah, the court. I think all of us are watching and wondering these big organizations like Google, OpenAI, Anthropics. There's a race going on clearly that we see. It appears right, and I think
Mhm.
generative AI definitely plays a big part of it. But when we talk about AI, I still think even at the fundamental aspect of it, there are misconceptions that I see between what's the difference between AI and machine learning, and why do we need to understand the difference?
Um, it's not a huge misconception these days, and people prefer to use AI because it's sort of like it covers more, and it's easier to understand than the machine learning. And AI is just any intelligence that is not human or not natural, I would say, right? Not made by nature, right? And
Right, right.
in that case, any program with a bunch of if statements is AI, right? Because it's some sort of intelligence, maybe very dumb intelligence, but still, and it's artificial, right? If you can make a machine that is made of would, and it does some calculations and answers some questions, technically it is AI, right? Machine learning, it's a different animal. It is AI also, but it specifically requires for machines to have some sort of um, application, I would say, in this case, and pieces of data which let the machine learn from either like outside world, the same way that humans do, right? Or from some set of data. That's machine learning, and that's the biggest difference.
So you mentioned that starting Monday, your new role is going to be really focusing on helping people get their
Mhm.
use cases into production. Um, what so before we go into, I want to get into some details around that and how
Yeah,
people
yeah.
are successful. Before we do, cur- the technology is so fast and things change every single day. What sort of trends do you see shaping up in terms of real use cases that people can focus on? And Google, gosh, I've read through some of them and there's hundreds. It's amazing to me how many. But where do you really see that there's a trend or where there's true benefit you will get immediately from what's going on today?
Um, there are multiple pretty big trends, and with the recent announcement from Google and even our competitors, you can see that one of the like huge trends is multimodal input and output, right?
Yeah, I love that. Mhm.
Um, this chat kind of interaction with large language models, and we can talk about it in details why chat is the most natural way. But
Yeah, I
chat
do.
was yeah,
Okay.
chat was the first, and many people actually thought that text is enough and more than enough, and we can just like stick with text. In many cases, it's not the most efficient, both from the experience point of view and the way even like the model thinks. Sometimes it's better when you add audio or images. Obviously, from the consumer point of view, being able to interact with your voice, and I don't know, at some point with the video, both like for output and input, uh, it it's just more convenient, right? It's more natural, and that's what we see coming, and it becomes real, which is the best thing. Like, think about 2 years ago, we couldn't think even like, oh, can I interact with a model with both text and images and audio, and it's all at the same time. Now you can, and beside the interaction itself and understanding what you want from the model, the model actually can solve also, pretty sophisticated problems in the background, whether they do it naturally through core LLM capabilities or with additional um, what is it, tools, as well as when this whole system is built as a set of agents, that even opens like more potential scenarios, and that's another big trend. So I'm kind of switching gears from multimodal interactions to um, agentic scenarios, right? Agents, they become a big deal, and one of the reasons, like if you start looking at best practices for using LLMs, you will see that when you define the role of the model, like you are a data engineer or you're a business executive, you're a marketing manager, you're project manager, right? The model tends to behave better for that particular role. And there is a reason, because model has a lot of data that it's trained on, and it's pretty much like a huge composition of different roles, but we all want the model to do a certain piece of job, right? So when you can focus model at a certain role, at a certain set of tasks, it tends to be more precise. It tends to what people call hallucinate less, because
Right.
you effectively limit the universe of the model, right? Because it has this all different, like all possible outcomes. You tell something to the model, and then it can answer with a lot of different outcomes. When you
Right.
focus the model at certain set of tasks or roles, um, the precision increases. That's the way LLMs work. So, but then any real world problem, especially when we're talking about business problems, it requires people with different roles, right? You have a
Yes.
business question, then it starts with someone asking that question, and then probably then you interpret the question, really, right? Because the question can be very uh, very broad or formulated in a very abstract way. Think about, like, who are my best customers in the US?
Right.
What does the best customer really mean, right?
Right.
Is it
What's
the
the
one that
definition?
makes you the most money, or the one that you interact the most, or the one that has biggest customer satisfaction, etc., etc.? And then that someone needs to interpret that question. Or when the interpretation, when a straight interpretation is not possible, then it needs to ask you back, like, what do you mean
It
best?
should, yeah,
Or
exactly.
these are the options that you have for definition of best. So these are kind of nuances. You need different roles. When you're saying naturally, you would need people with different roles to complete the flow. So now, when we talk about using generative AI for solving these problems, we say, oh, what if we use multiple agents, and each
Yes.
agent plays a different
Different
role,
role.
and that
Hmm.
way, when we have a proper way to orchestrate the agent, we can solve it more efficient way. And naturally, sometimes we can solve this problem versus not being able to do it because we are asking too much from the model.
Right. And I think what you're saying is that um, the more you can define the specific tasks and role, the less likely you'll get a nebulous answer, or one that's like kind of grasping at many different models
Yes.
that's non-specific to your organization or your business. Okay, so that brings up an interesting point, because I remember early on when I was interacting, or all of us, our teams were testing, trying to code or solve or ask questions. There was a real heavy emphasis on prompt engineering. And
Mhm.
early on, if you had to be, the better you were at describing the role that it should take on and those things, you definitely got better answers. But
Mhm.
in my opinion, as more people come online, um, hopefully the machine itself, what I was imagining, we were saying, if the different agents take on different roles, I would prefer it to ask me questions. I always even ask my own AIs, do you have a question before you answer? Do you want to
Mhm.
ask me any questions? Because for the very thing that you brought up around the semantics, like what we think or say one word might mean, or what is a good customer? A good customer could be the greatest margin, or they continue to, those are very important things I think people don't really take into account. So I understand that they have use case scenarios, but there are a lot of factors, I think, um, that will determine whether or not your AI is actually giving you answers that are productive and insightful, right? So that's when we get into when these use cases actually become production valuable. I want to get into more of that. You started to say, hey, well, let's get in a little bit deeper around natural language processing, right? And were you talking about LLM or just the way we communicate? You were
Mhm.
about to say something, but you were finishing a thought. Do you remember that topic?
Yeah, yeah, I do remember. It just in general, what I mentioned is that why chat was sort of like the most
Yeah.
natural way to interact with LLMs, and that comes from the nature of language models themselves and the transformer architecture that they pretty much all of them based on. Uh, the the way it's trained and the way we use it comes from the flow that assumes that we give the model a sequence of words. They call them tokens, but effectively, token, it's very roughly and with a lot of simplification, can be used as an equivalent of a word, right? So
Okay.
we give it the sentence with a set of with a sequence of words, and what the model is trained is to predict the next word. That's the very
Yeah. That's
basic, and like those base models that are not even trained to interact with us in the form of like question answering or instruction following. They just autocomplete machines, right? They complete sentences, they complete pieces of code, they complete documents, they just complete things, right? And the the reason we were able to produce these models, actually two key reasons. The first one is we finally got the power. And for the AI, it was always the case. Oh, do we have enough power GPUs, etc., or TPUs in the case of Google to train the model of this size. And it comes to a lot of factors, including how they build data centers, how they connect those devices together, etc. But the second, and that's the common problem for any machine learning, is data preparation. You need to effectively, to train the model, you need to have your question and you need to have the right answer, and then you need some function that evaluates how much that answer that the model the model gave you is right. How much that's again very simplified form of training. But the beauty of language is that internet, or even before internet, we had a lot of data that is stored exactly in the form that we would use for training. It's stored in the form of completed sentences, completed documents. So we can get the sentence, cut it in half. Again, I'm oversimplifying. Give the first part to the model, and then see what the model produces. Right. So we don't have to do all this work for data preparation, because normally it's a lot of manual work. It's expensive. It's long. People make mistakes, etc., etc. Here we have it ultimately for free, done already. Right? People just type things, and that's why language models, these large language models, became possible, because we have this data. And one of the first applications of transformer architecture was translation. But translation was, the way it was formed is like, translate this to language X, right? And then you give it the sentence, and the model sort of continues, basically, with a translation. Then someone smart decided, oh, what if we just make it continuous sentences of any arbitrary kind of information, and that's how this revolution happened.
That's actually fascinating. But as human beings, we do that, right? So as I'm listening to, or I'm communicating with anyone, a customer or project team member, or whatever, as we're listening, we're filling in that next word, and as a way to understand, maybe we got the next word correctly, but we know we're within, because of how we're wired, we know we're within the realm. So we can almost sometimes we can finish the other person's sentence. That's a very unique.
Yeah. And it's funny that you mentioned that, because there is a book that's called 1,000 Brains Theory, which describes how our neocortex works. The one in the brain. And it has a different kind of cells and different parts of neocortex that work at different levels of abstraction, starting from processing our sensory data and down to processing things like politics and math, like very abstract things. But ultimately, all those little cells and the group of cells, how they call them cortical columns, they work in a very similar way. All they do is they get input from the sensors or from the previous layers of abstraction, I would say, right? And they predict what's next input is going to be. All they do is predict the next thing, right? They get the sensory input, they get information about how we move our sensors, right? So how our eyes move, how we move our hands, ears, etc. And then we predict what's going to happen next. When the result is different, and it's normally always different, right? We adjust our weights, right? Our parameters in the brain, and that's how mammals and all mammals have neocortex. That's how we learn. So, and the language, it's just a new level of abstractions. All we do is we figure out what's the next word is going to be,
right?
Which is very similar to how our brain works in general.
Right, but that's also that's why, like you said, we don't have to do that kind of training anymore to actually communicate with these machines now, because it's picked up on that. So that kind of leads us. So now, okay, we've solved that. From a business perspective, how do we leverage that? Where, now we can really look at things and become more efficient, faster, right? So we started off, talking about your original interest to come over to this was data and analytics, right? And this is something Comerit. This is where we're focused. You know, Joe. Joe was one of our top guys here, very big on data, and so we have this ability now to communicate with the machine. But as you and I discussed prior to getting on the podcast
Mhm.
about my NFL picks and how sometimes uh the most critical component is like, yes, it knows how to talk to us now, but ultimately getting the insightful actions to take is a result of the data that's harmonized together. And from Comer's perspective, that's the challenge that we see people will still have. Like they'll have great use cases or whatever, but bringing in information from your Salesforce or your CRM, bringing in your ad data from Google, bringing in your big query data that's ERP related, bringing those things together. Those things as human beings we do kind of naturally. We don't have to really query those things. We have a conversation to, some executives come together, we have some conversations, hey, I looked at this, and then somehow our brains come up with an idea or an intuition or something to do. But in order for the machine to do that, how I know you guys have GCP and SAP has Datasphere and there's other tools out there. What are your thoughts about like really getting to that point where the data is so true and accurate that now when you apply these AI use cases on there, they're incredibly meaningful. Like we're really going to see, real optimizations. What are your thoughts around just that whole concept of, I guess
There,
truth data?
there are multiple layers of that, right? And um, when we talk about interacting with LLMs or any generative AI scenarios for data and analytics, we often get like the first example that people normally get is conversational analytics. I have a question like, who are my best customers, right? And then we convert it to a series of like other questions, the definition of best customer, blah, blah, blah. Then let's say we have some interface to the data. Let's assume it's SQL. We convert those other questions to SQL. We query the data. Then we get the numbers. We can generate what's called a diagram, right? Some like chart with the data visualized, and then people can make decisions, right?
Yep.
That's sort of the typical scenario, right? In the reality, there's way more steps like
Yeah.
before and after. Like the usual question that I'd like to ask, like why asking about best customer? Like what is the real problem you're trying to solve?
Yeah.
Like, do you want to visit them? Do you want to like send some, I don't know, emails to them? Like, I don't know. What is the reason you're asking that question? And because when, let's say we don't have LLMs, like pre-LLM era, right? We
Yeah.
had this big dashboards with a bunch of, diagrams and graphs and etc. And some people actually had an idea like, well, we need that kind of dashboard. This is what I want to see, right? And so they were trying to collect all these little data to actually interpret it somehow and come
Yep.
up with an insight, right? Now, where can LLMs help? Like, obviously, yes, LLMs can help build this dashboard at first. Like, so you ask the question, LLM can give you uh, with some prompt engineering, obviously. LLM
Yeah.
can give you a SQL, can generate diagram code for you,
Oh, I've seen
etc.,
some of the
and
looker
you
stuff.
can put it
Yep.
together. But it's really kind of one-time job, right? Like
Yeah.
you've done it once, even if it made mistakes, you can correct it. You
Sure.
can get business and like analytics people involved. You can get BI people. You can get data engineers. You pay them once, they build a dashboard for you. The interesting thing starts after that. So you have this dashboard, and then you look at it and you start asking additional questions. Oh, this, let's say, sales for this kind of product category, how does it behave within the northwestern states of the US? right? And this is where, like, normally for humans, it's not a big deal. They go to states, they filter out,
Yeah.
And they give you this version. But oftentimes those dashboards, they're pretty static. You don't have this flexibility
Right.
because you don't know what questions they're going to ask. And this is
Right.
where LLM can really help you. When you have this first
Oh,
set
I
of
see what
data
you're saying.
models,
Yeah.
you
Yeah.
have this first set of data models, and if they're well made, LLM will be able to understand, oh, what are the adjustments that I need to make to present you a different version of this data with these
Right.
digital questions. Another layer of that is like, how do I interpret your question?
Right.
Northwestern states of the US. Nowhere in your data you have a flag that says, oh, it's Northwestern state of the US. So you actually need some logic to figure out, like, how do I get the customer address and understand that the customer is in the Northwestern state of the US? Or take Orange County.
Yeah.
Of California. How do I know what are the cities that are included in Orange County? So this is where additional tooling comes in place, additional logic, and there's like many layers of that, and that is what differentiates a demo from a production system. You
I
get
see
those
what you're
tools
saying.
involved.
Yeah.
You like, and a lot of those little agents that actually can interpret your question before you even get to generating SQL, etc. Like,
Right.
etc. So that's the layer that comes sort of like before we start doing any substantial work inside with the code,
Right.
because like LLMs, they cannot just take your Salesforce database, even if it's, I don't know, replicated to BigQuery, and all those gigabytes, sometimes terabytes of data, interpret. They won't fit to what's called LLM context, right? We have 2
Right.
million tokens with Gemini Pro 1.5 today, but that's pretty much maximum, and it's still a lot. So
Yeah.
it's more important to have well annotated data models that can be interpreted by your LLMs and can be used.
So that is
Um,
a key
mhm.
point. Well
Yeah.
annotated data models. It's
Yes.
critical. You can't go to the next step without that. So, what kind of products and or services or tools does Google offer to support that? Like, knowing that these are critical areas. So, what does Google bring to the table that helps support that?
I think the closest that you can get today is a Cortex Data Foundation, the team that I'm still on for 2 more days. There is a concept of data mesh, which is basically about annotating data models. Data models themselves are a huge factor because for applications like SAP, the way you get the data from them is vastly different from how it should be interpreted. Same applies to less sophisticated systems such as Salesforce, right? This is my favorite example. You get data about your opportunities, so you start comparing who's your most profitable customer, let's say, right?
Yep.
So you have, let's talk about even the revenue, just the amount of opportunities.
Yep.
But they all, like on any big organizations, especially the multinational organization, you have those opportunities as different currencies. So that aggregation of data that happens, you have to convert it to a single currency before you start comparing them. And this normally doesn't happen just like over the data itself. You have to take care of it. So you need to have some data model and some implementation of the data model in your, let's say, data warehouse, or a different way of representing it. Let's say Salesforce has its own that does that conversion and allows you to do this aggregation. So the model can at least find this data model and
Correct.
use it in when it generates any kind of query language to present you with the data or to further analyze it.
Yeah.
So
No. No.
those kind of little things are important.
Yeah. It's all. This is great advice, and I know that our customers and people looking at they're looking at Google as a way to bring all this data together. This is going to be a great podcast for that. Um, I'm going to switch gears a little bit. I
Mhm.
want to ask you about any advice you would give to people now. They're what I found out over the last few months. There's a lot of programmers and a lot of people coming out of college, and they're realizing that they're going to need to make a shift in their knowledge over to what's happening over in the AIML space. Is there any advice that you can give to those individuals? Um, where do you see Google and this technology is going to be in the next 5 to 10 years? Just based on where you're at right now.
The events of the last couple of years showed me that predicting anything for the 5-year period, it's like it's impossible.
But can't we run that through AI?
Yeah, it just runs way too fast. And but the one thing that stands out to me, and despite a lot of claims, so it's my personal opinion, because even at Google, I have plenty of people saying, "No, that's not going to be the case." Learn how to code, because even when you do prompt engineering,
yep,
it requires a lot of the knowledge of what happens underneath. Like the best prompt engineers I know, they are actually software engineers. They are software engineers.
Totally agree.
And the models, similar to people, like they're good at some things, but they're horrible in processing vast amounts of data. So vast amounts of data are still going to be processed by traditional computing before like we get outside of those Turing machines that we have, right? So when the next wave of computing comes, but that's not going to happen definitely for 5 years. So we're stuck with this kind of computers that we have today, and those require programming. And whether LLMs write that code for you, or you write the code themselves, knowing what's going to be written is extremely important. Whether it's a high-level language, low-level language, the way of thinking that coding gives you helps you with the
prompting.
Just like interacting with machines helps you with prompting.
I 100% agree. So I would say, I mean, based on that a lot of my developer friends are probably still safe. In terms of, I agree with you, Vlad. I think that their background actually makes them the most proficient prompt engineers out there. And it's actually exciting because I think, in my opinion, the heavy lifting, like doing that big set of code, development, we don't need to focus on that, because if you can truly prompt correctly, you can get the bulk run down. And then now you just go in and you're fine tuning, but you do have to know how to speak the language so that you can see what story the AI might have been telling through whatever code generation it has in order to make fine tune adjustments. So that I agree with you. And I think I have a neighbor who he was asking me about this. He's like, I want to become a programmer, but really concerned we won't need programmers. And I said, well, it's just my opinion, but I think being a programmer makes you more valuable as we utilize AI for production type scenarios. So no, that's great advice. And I know we're running up against some time. I've taken a lot of your time. I so appreciate you joining me. Before I close out here, are there any other hot topics you'd like to share, or you think we may have missed in this session? I know I had a lot of questions.
That's the one thing I kind of wanted to continue actually on what you touched, because previously when we had a conversations, you also mentioned AGI and how whether it's coming in.
Okay,
there's a lot of
I didn't want to bring that up
AGI.
in case I forgot to clear that with you prior. I wanted to bring that up, but I usually clear that question first. Let's have that discussion.
So I don't want to predict where AGI is coming. And I would say a lot of people do have different definition of AGI.
Okay, that's
again, for jobs like programmers, right? And I like the way you call them. Like the programmer job is probably going to stay. The way we do programming can change vastly, but it's
Yes.
still the way of thinking is the most important part. What what's in the biggest danger with uh, with the AI coming? And when I say danger, it's not about people being in danger. It's about actions, or I would say, um, uh, some of the jobs that we're doing. Right, the more automatic they are, the more like kind of boring and non. I would say kind of the jobs that can be automated easily.
Mundane type stuff.
Data
Uh,
extraction, data
Yeah.
conversion, just those simple things. This
Mhm.
is where the machines are coming to solve, because it's first of all, it's boring. I'm actually happy that they're
Boring.
going to solve it.
Right. We could all
And
do that.
like filling forms, understanding forms, again, like I mentioned, data conversion. That's the biggest thing to automate. And AGI, we may never see it like a true AGI, when just like machines are truly better than human at everything. Machines, they don't have this, maybe I'm not saying like a sensory motor way of learning. We just learn way too fast. Machines cannot learn this fast. It will take the machine to learn like the business a long time and make a lot of mistakes. So we need humans to tell the machines like a lot of key things they need to know about like a certain business. But when you are like, let's say, when myself, if I write simple scripts every day, to automate some spreadsheets, etc., then yeah, AGI can actually happen tomorrow for me. And
Yeah.
that's the thing I'm trying to say. AGI is actually going to come for every individual at a different time. Like
Yeah. I
when
That's an interesting concept. Yeah.
yeah,
Because
and
it's role we're back to roles, right? So
yeah, it depends on the role, and it depends on like a vast majority of actions. Like today, let's say you want to file taxes,
right.
you better have an accountant to file taxes right. And
Yeah.
then imagine tomorrow they decide to simplify the tax system, and with the level of machine learning we have today, if they simplify the tax system, AGI will come for those tax filers
Right.
immediately, right? It's probably not going to happen for many
Right.
reasons, but that's
For
that's
for
how it
sure.
can happen potentially. So
Yeah.
that's sort of the what I like my take on AGI.
Okay,
Whether it's
so none of the movie script stuff that we talk about. Have you seen the movie Ex Machina?
no, I haven't.
Oh, it's great. I'm really big into these sci-fi movies. One of my favorite movies. It's about a big computer company who's working on this sentient brain and robotics, and it's really interesting because at some point it doesn't just realize that it's a robot, but it has its own thoughts, and it's a great. I don't want to ruin the show for you if you get a chance to watch. It's really fun to watch to see like these developers, the way they're thinking about a sentient being, how the thing actually begins to um, have its own realization that
Yeah, it's consciousness.
it's
It
conscious.
becomes having
So
consciousness.
there is an interesting post, and I'm going to end with this. Yesterday was an interesting post. So I went on the chat GPT like I'll often do throughout the day to just kind of check a thought that I have, and it was down. It said, "Oh, we're sorry. We recognize there's a
Happens.
problem, but it's not running." And it was blank. The whole thing was blank. And it's just some few words. Then shortly thereafter, there was a post that said that this was really funny. They said that uh, OpenAI was working on doing an upgrade, and that the current AI recognized that it could potentially change its model, and it shut itself down so that it did not lose its what it knew itself to be. I just thought it was hilarious. But So this is the other definition of being sentient, is that the thing's so informed, so well informed that it understands that it's, regardless if it's human or not, it knows it's an existence of some other intelligent comprehension. It's amazing. It was just funny. It was fun to think about, mostly sci-fi related, but who knows? Like you said, things are changing so fast. Sometimes it's hard to know, like, am I talking to a machine? Is it just repeating like what it knows to say next? But for now, it's still fun. And I think, um, I appreciate you sharing all of your knowledge. I think there's lots of opportunities. I'm looking forward to working with Google on all these business insight opportunities. And I really appreciate you sharing your time with us. And hopefully we'll get to have you back on when there's another new announcement and we can talk about those. So,
Certainly.
Vlad,
Thank you for having me. Yeah, I had a lot of fun. Yeah,
yeah, it
I
was
hope you
great.
enjoyed the show.